So this is just a continuation. So some of you folks wanted me to do 7.1 through 7.3. So that's what I'm going to do for each of these next few sections. So I have 7.1 continuation, simplifying rationals. And what we're looking at is if I had a rational with just real numbers, like 8 over 12, if I want to simplify it, I have to say, well, what goes into both 8 and 12, and see if they have anything in common, and then cancel that. So I know 8 is 2 times 4, and 12 is 3 times 4. So anything over itself is equal to 1. So those two would reduce to a 1, and I'm just left with 2 over 3. So with real numbers, it's a little bit easier to do, but we also have to do that with variables. So if I have my next example, I have to have 28r squared times x. And then on the bottom, I have 10r times x cubed. Sorry, that 28 looks terrible. Then I need to simplify each one separately. So the real number parts, and then the r's, and then the x's. So I'm going to start with 28 over 10. And what number goes into both 28 and 10? So 2 would go into both. So 28 is 2 times 14. 10 is 2 times 5. So these 2's would simplify down to a 1. And then I want to look at the r squared over r. Well, this one r on the bottom would knock out one of those r's on top. So this r is going to be gone, and it just becomes a 1. And this exponent up top becomes a 1. And then lastly, I'm looking at my x over x cubed. So again, this one x on top is going to knock out one of the x's on the bottom. So that exponent becomes a 2. So what do we have left? I have a 14 times r times 1 on top. So that just gives me 14r. And on the bottom, I have a 5 times x squared. And then I'm just going to double check to make sure there's no other common factors in the numerator and denominator. And there's not here. So that is completely simplified. Here in my next example, I have x squared plus 3x all over x squared. So I can factor my numerator, and I factor an x out, and I'm left with x plus 3. And then I have an x squared on the bottom. So this x on top will knock out one of these x's, so this is going to be gone. It just becomes a 1. And this exponent down the bottom becomes a 1. So I end up with x plus 3 on top and just one x on the bottom. Alright, our next example, I have y squared plus 5y plus 4 over y squared plus y. So here I need to factor both the numerator and the denominator. So y squared plus 5y plus 4 factors to y plus 1 times y plus 4. On the bottom, I can pull out the greatest common factor, so I can pull out a y, and I'm left with y plus 1. So this y plus 1 factor and this y plus 1 factor simplifies to a 1. And I'm left with y plus 4 over y, and that's as simplified as it can be, right? Because I can't cross out anything unless I have the exact same factor on the top and the bottom. There's a y down here, there's a y plus 4 on top, so they do not simplify. So this was one of the special cases, I don't know if you remember, but when we have these the numerator and denominator are exactly the same, except for they differ by a factor of -1. So this whole thing just simplifies to a negative 1. And the reason that that's true is, let me just rewrite this. If I take the numerator, let's say, and factor out a negative 1, that 3 is now going to be positive and the x is negative. So I'd get negative x plus 3 over 3 minus x. Well, these are the same, right? Because these are both positive 3's and both negative x. They're just written in a different order. So this simplifies to a 1. And I'm just left with negative 1 times 1, which is negative 1. So anytime you see the numerator and denominator just switch signs, but the terms are the same, it's always going to simplify to a negative 1. So another example of that would be 2x minus 3 over 3 minus 2x. 2x is positive on top, negative on the bottom. The 3 is negative on top, positive on the bottom. So this just simplifies to a negative 1. And as long as you can see that pattern, you don't have to do any extra work for that. So I'm just going to do a couple more examples. I have x squared minus 4x over x. So again, I can factor the top. I can factor an x out. And the greatest common factor, so x times x minus 4 over x, that simplifies to a 1. So I'm just left with x minus 4 over 1, but I don't really need the 1 on the bottom. If that x minus 4 was on the bottom, then I definitely would need a 1 on top, because we have to make sure what's in the numerator stays and what's in the denominator stays. Right, I have 2y squared plus 10y plus 8 over y cubed minus y. So first I can take out a greatest common factor of 2, and I'd get y squared plus 5y plus 4. On the bottom I can factor out a y, and I'd get y times y squared minus 1. And they both can be factored further. So that would be 2 times y plus 1 times y plus 4 on top. And then this y squared minus 1 is the difference of two perfect squares. So that factors to y minus 1 times y plus 1. Now that it's completely factored, I see that they both have a y plus 1 factor. So I can simplify that. And that's it. There's nothing else that matches on the top and the bottom. So my answer is just 2 times y plus 4 on top and y times y minus 1 on the bottom. And let me do another one with where you don't actually have to factor. So we get negative 18 x squared y over negative 27 xy. So a negative over a negative is a positive. So I know that's going to cancel. And then 18 over 27, well 18 is 9 times 2. 27 is 9 times 3. So those 9's cancel and I'm left with 2 over 3. Remember, x squared means x times x. And then I have an x on the bottom, so those cancel. And I'm just left with an x. And then I had a y on top and the bottom, which are exactly the same, so those cancel. And when I say they cancel, they're canceling to a 1. They don't cancel to 0, right? So what do I have left? 2 times x on top and a 3 on the bottom. And that is simplified form. So go back, do the homework problems, make sure you do the classwork. Even if you did them before, you can just recopy the problems and redo them out. And let me know how it goes.